Hi everyone, thanks for joining us. This is going to be the first Tech Lunch and Learn that we'll do this season. We'll also have a second Tech Lunch and Learn which will go over some more troubleshooting and installed troubleshooting calls that we get into tech service. But for today, what we're going to take a look at is the new FER blower setup along with the wiring diagram and how you go about troubleshooting this new blower motor that you're going to see on single stage furnaces. Now, this blower motor that you'll see will be on the new single stage furnaces along with on manufactured housing, like on the M1 series, for example, will have this same blower motor. As far as troubleshooting is concerned, it's going to be exactly the same as you would see on a G7 and an M1 series furnace, which we'll talk about. But for today, we're going to take a look at a wiring diagram off of a G7 and look at some things that are still the same that will be familiar to you in the field, along with a little bit of changes that we had to make in order to have the new blower motor to meet FER standards. So let's take a look, and if you have any questions during the presentation, please submit those and we'll get to those at the end. So the first thing that we'll take a look at is just some physical changes to the actual board itself, which aren't a lot, to be honest. So what we have here is the relays at the bottom of the board are going to be a little bit smaller, and that's because the relays are going to be carrying 24 volts AC current to that blower motor. So basically we just were able to shrink the relays a little bit because they're not carrying full line voltage, which would be 120 volts. And those relays are going to be the relays down here at the bottom of the board. Also too, what you'll see is a 24 volt jumper on this board. Now, I don't have it in the picture here, but essentially it'll be from the top of the board here down to a terminal here. And basically that's just in order for us to get 24 volts down to the other side of the board. Leave that wire on or the blower motor will not run. So just leave that wire in place, and that is going to be factory installed. Also too, so I kind of mentioned this, the blower motor on the single stage furnaces are going to change from a PSC motor to this new ECM. Now, this ECM is going to be a 5-speed blower, and you may be wondering, well, there's maybe only 4 dip switches or selector switches on the actual board, and how do I get a potential 5th speed? We'll take a look at that in the wiring diagram. It'll be a lot easier to see that once we get there. Also, kind of as a side note, there obviously will not be a capacitor on this blower motor, so that's one less part that can fail. So ECMs do not require capacitors. And then also, the blower motor itself will have a line and low voltage going to the motor. So you will have 120 volts going to that motor, along with a 24 volt VAC current that will be, again, at the bottom terminals here. These terminals down here are going to be your 24 volt VAC current. And then also too, something that hasn't changed is actually setting your blower speed. So at the very top of the board here, you have your selector switches. They look kind of like light switches. So you still have your high, medium high, medium low, and low selector switches here, and those haven't changed. Now, what has changed a little bit is how those blower selector switches will translate to the actual motor and what speeds you're actually running, which we'll take a look. Also too, we'll take a look at some blower charts, and those dip switches really haven't changed for you guys in setting up your blower speed. Okay, so for troubleshooting is concerned, it's very straightforward on this motor. Essentially, what you'll want to do is confirm that you have line voltage and low voltage going to the motor. So again, what you'll end up doing is measuring your low voltage. Say you're in cooling mode and you're on high speed and cooling. where you'll place your actual meter leads is on your high-speed terminal down here, 1 meter lead, and then your other meter lead will be up on a common terminal, which will be at the top of the board. So again, as long as you're measuring low voltage and line voltage going to the motor, and if that motor's not running, we need a new motor at that point. So just confirming both voltages and going from there, whether that's a board potential problem or an actual blower motor. Okay, so what we'll take a look at now is the actual wiring diagram. Now, the wiring diagram hasn't really changed. What has changed on this, though, is the wiring in relation to the blower motor. So what you'll see differently than on an older, say, G7 furnace wiring diagram is this part right here, and this is the blower motor. So like I said earlier, you still have your 4-pin plug down here. These terminals have now switched from a 120 volt to a 24 volt voltage. So again, these are your low voltage terminals here. And then on this wiring diagram in bold, you have a black and a white wire that are coming off this plug that then go over to your blower board. And that's where your line voltage comes from your board. So what you'll see here on this wiring diagram is you'll have, if you follow these wires that come off this 4-pin plug that link up with this 9-pin plug, you'll have 2 extra wires here that are not actually attached to your blower motor plug. Now, for this actual wiring diagram, they're not there because I actually don't know what BTU furnace this wiring diagram is off of, but essentially what you'll do is you'll place these 2 wires on the actual blower motor plug, and that'll give you a desired blower motor setting for speed and CFM. So again, on this plug you have terminals 1 through 5 here. You then also have your line voltage here along with the gray wire that is down here, which is your 24 volt COM going to the motor. So you have 5 terminals that are here, and again, like I said earlier, on the actual blower board you'll have your selector switches here, which are only 4 speeds. So if you wanted to get that 5th speed for cooling, which we'll take a look at in the blower chart, essentially all that you have to do is unplug one of the wires down here and then plug it into the port that's not occupied. In the blower chart, we're labeling that as the alternate blower speed because we didn't really want to confuse people when we use, say, low, medium, and then medium, high, and high. We didn't want to try to confuse people with that with the dip switch setting on the actual board. So we're just going to use the word alternate as your speed that's not being used but is available to you for a cooling or a heating application. So again, that is the wiring diagram for the single stage furnace. Again, it really hasn't changed other than this area here, which is with the blower motor. So the next thing that we'll take a look at is the new blower charts. So first thing with the blower charts is that we are separating the cooling and the heating blower charts. On the older stuff that you will see on the tech library and that you're more familiar with is that we had the cooling and the heating in the same chart. So per FER regulation, we have to separate those 2 charts, and then the heating and the cooling are as far as duct static pressure is concerned, and we'll look at that. It's a little bit different for duct static, but again, we'll get to that. Also, too, the alternate speed that I talked about on the wiring diagram, that will be different on each BTU furnace. So the alternate tap, let's say on a 54,000 BTU, for example, is number 3, where we have it as alternate. On, say, a 90,000 BTU, the alternate tap may be actually tap number 4. So again, that's why we didn't get into the whole labeling of the blower speeds, and we're using alternate because, and this is all getting back with FER and how we can label stuff and where we can set blower speeds. It'll be different per BTU. So just keep that in mind when you're installing furnaces, and just make sure we set the blower speed up correctly on that. And also, like I said, as far as the CFM data is concerned, the heating chart that we have is rated from a 0.1 to a 0.5 on your duct static pressure. And then also for the cooling, you'll have between a 0.1 and a 0.8. So you'll have CFM ranges between those two ranges on your duct static pressure for information and help you determine where your CFM is at on your cooling and your heating speeds. Okay, so what we'll take a look at here is on a G7 SA furnace, which is a single stage 80%er. This is the heating chart for the furnace. So as far as the chart layout, it really hasn't changed from what you guys are familiar with. You still have your model number, and then on the far left side, and then you'll have where your return is at, whether you have a bottom, a side, or a side plus a bottom return, and it will give your according CFM data here for you. Now, sometimes on the BTUs, you won't have 3 tiers of CFM. One of these may be in the same chart, and that's because we recommend once you get up to a certain CFM level that you automatically have 2 returns. So, but this is going to be the heating chart. Again, your duct static pressure goes up to a 0.5, and then per this example, you see on this BTU furnace, our alternate is speed tap number 4. So number 4 is not occupied on the actual blower motor plug, if you will. Now, also, what you see here are some grayed out cells. Now, per FER regulation, we cannot tell you to put your blower speed in a grayed out cell, because at that point, if you do, you will not be FER compliant with the blower setup. Not to say that it won't work, you know, not to say that you can't put your blower speed on high or move a tap up to the number 4 and get that, that alternate speed for heating. We, as in tech service, cannot tell you to do that, because if that furnace were to get inspected and the inspector were to look at the blower chart and see if a high speed, or let's say in our case on this diagram, or if the number 4 is occupied, it should not pass inspection and you won't be FER compliant. So just keep that in mind. Straightforward answer is it'll still work, but we can't tell you to do that in tech because then we're falling out of FER compliant. So yes, so this is your heating chart, and again, just real quick again, that alternate speed will differ based on what your BTU. So ours is a 54,000, and just so happens on the 54,000, again, number 4 is the alternate speed. Okay, the next chart we'll take a look at is the cooling chart. This really, again, hasn't changed. We just separated the 2 charts for you. Like I said, the duct static pressure will go up to a 0.8 for your data on that, so from a 0.1 to a 0.8. Again, at the far left here, you'll have where your return is and in coordinates with where your CFM levels are going to be. Now, again, we still have the number 4 for our same BTU furnace as the alternate speed. So with the cooling side, you can use any 5 speeds that you want to. You're not, as you can see, there's no grayed out cells on this blower chart. So you have full range of this blower chart, or speeds, if you will, at your disposal. So again, if you wanted to, per your duct static pressure, use that number 4 as your alternate, all that you have to do is unplug one of the wires. Let's say you wanted to move your medium high speed up to the number 4 speed, for example, you know, to make sure you got your CFM per your tonnage, and you wanted to use your number 4, all you'd have to do is back on the wiring diagram is unplug that wire, move it to tap number 4, and then boom, that'll get you directly into your alternate speed on that. So like I said, nothing has really changed on this blower chart. The cooling chart goes up to a 0.8, and you have full range of speed taps available to you to reach that. And that's kind of what I had for you guys today in regards to the FER blower motor setup and the troubleshooting, if you will. Go ahead and submit your questions. I'm going to take a look at those and answer those for you guys. So feel free to anything on this topic, just submit away, and we'll answer those questions for you. Again, this new blower motor setup is going to be on the new furnaces that you most likely will be installing this fall and into next year, and so on. You know, because as of July 3rd of this year, everything produced after that date is going to have this same blower motor setup with the ECM blower motor. Again, it's going to be on the single stage residential furnaces along with the manufactured housing furnaces, and the troubleshooting is going to be exactly the same as far as just confirming the line and low voltage to the blower motor. But yeah, so I just want to make sure it's abundantly clear when you guys either open the box and realize, hey, this isn't what I'm used to, and you know, how do I go about, you know, setting this furnace up for proper operation on that. So let's take a look at your questions and see what you guys got. Thank you. All right, guys, so that was kind of the FER motor lunch and learn that we put together for you guys. Let's take a look at some questions. Some have been coming in throughout the presentation. If you, again, have any questions on this particular subject, feel free to ask away. I know a lot of this information is really straightforward stuff, but again, if you have any questions or concerns at all, feel free to submit those, and I would be happy to answer that stuff for you. So let's take a look here, and we've got some stuff coming in here. So the first question is what type of motor is the FER motor? So how I would label the motor would be a constant torque type motor. It's not a variable speed motor, you know, like you would have in a G7 two-stage furnace, if you will. So it's a constant torque. It's an ECM type motor as far as the labeling of the motor itself. So it's very similar to the package units type motor on those. It's a same kind of deal. Troubleshooting should be pretty familiar to you guys on troubleshooting those motors along with the ones on the new FER furnaces, but again, it's just a constant torque if you were to get that question. Another question is, let's see here. Is line voltage applied to the motor at all times? The answer is yes. So line voltage, which would be 120 volts, is applied to that motor at all times when the furnace is powered up. What will then bring the motor on is the 24 volts AC current that will activate the motor, you know, depending on what speed you have selected and what motor tap you have selected. So per that question, yes, the motor will have 120 volts going to it at all times, and then comes on as soon as we have a call for either heat or cool off of the 24 volt tap on that board. Okay, next question here is, will FER apply to air handlers? So on the air handler side, the FER regulation, if you will, does not affect air handlers. So basically the best kind of answer I can give you there is that an air handler's primary source of heat is not a heater kit. They deem it as a heat pump as the primary source for the heat. So the FER standards, if you will, did not affect air handlers. So on the B6, B6B MMOs and B6B MMX air handler, for example, would still be able to have a PSC motor in that particular unit. So the FER, again, just applies to the furnaces, which would be the residential side, along with the manufactured housing side, which would be your M1 series furnaces, which is your 80%, and then you have the high efficiency side of that too would be the same type motor on that. Okay, so another question is, so I kind of answered that, if you will. One guy's asking, does it apply to air handlers? So no, it doesn't apply to air handlers. And package units, the package unit side does not apply to the FER that I'm aware of on information I have. So a lot of the package units that we do have already have the ECM motors in them. It's a very similar type motor. Again, it's going to be an X13 constant torque type motor, basically the same thing, just different terminology. So it's still the same type motor, but no, to my recollection, it's just the furnace side on the FER. Okay, another question is, when will the part numbers of the new motors and control boards be available? Great question. To my knowledge, and I can double check on this for you, but I'm pretty sure they're in the replacement parts list for the furnaces, because the tech specs and that kind of information is available on the literature library. So the part numbers should be in the RPLs for those furnaces for you guys. If it's not, I can double check and make sure that that information is on the literature library. But as far as where you would go, you would be going to that source, the literature library, or you can call into the office and talk to the parts guys, and they can look that stuff up for you. But I'm pretty sure we do have that stuff available on our website. Okay, so another question here is, when you call for G or fan only, what will the blower speed be? So that would be your cooling speed. It's going to be very similar to the previous board on what your G call would be, or fan only, if you will. So it would be the cooling speed on whatever you have that set to for fan only call. A lot of great questions, guys. If you have any other concerns or questions on this topic, please ask away. I know we talked a lot about this stuff at the TSA conference, so a lot of this stuff is actually probably pretty fresh for you guys through tech tips that we did, along with a furnace class that I had put on at the TSA conference and stuff like that. But again, if you have any other questions, feel free to ask away here. We have been getting questions on the new M1 setup as far as the wiring diagram is concerned. That's something that crossed my mind. So from my memory here, I believe we have the Y wire going to G. It's a common question we're getting, and the reason why we did that is because we had to output 24 volts from the board, and again, this would be like, say, on an M1 furnace, manufactured housing. We had to do that in order to output 24 volts on the cooling tap for that board, which would be a low voltage tap, that would then be going to one of your 5 blower speeds on that motor plug. So that is correct, just so you guys know, if you guys were to have that question come across in the field. So that's something that we have had in tech recently on this. Another question here is there a way to have a continuous low-speed operation for the motor? Maybe in an alternative heating application, or if you're dual fuel, from what I'm getting here. Basically, it's either going to be one of your speeds 1 through 5. There is no say lower speed, if you will. It's whatever you're having a cool call or a heat call, whatever you have set for, whether that's the switch on the board between the 4 speeds that would be available to you on the board, or if you use that alternate speed, that's where the motor's going to run. So unfortunately, kind of like the variable speed and the 2-stage furnaces, where say a G call wouldn't be full blast when you would have a fan only call. This is very similar setup to the previous style on the G7 furnace, like the G7 SA, for example, on that. So there's not a way to run a lower speed operation on that motor. A lot of good questions, guys. Again, if you have anything else on this subject, please ask away here. Let's see, another question from Dan. His question is, does the blower motor come with the blower control portion? Dan, I'm assuming what you're asking is the module for the motor, from what I can gather from your question. So like on our other motors here, the module and the motor is going to be an all-in-one deal. So on the RPL that we're referencing for the E7, it should be just labeled blower motor, and that's it. So you're going to have the module, the motor in one case, if you will, or one housing for that motor, and there would not be 2 separate controls there. So essentially all you would have for the blower motor would be your control board and then the motor itself, and that would be it. If you needed wires for that, Dan, it should be under the set of wires, is what we label that on most RPLs. If we needed a new wire harness or something like that, it should be under that particular part number. Great questions, guys. Also, just a quick reminder, the next Lunch and Learn is going to be October 22nd. It's going to be over basically a refresher of May's FER Lunch and Learn that we had shot back in the spring. So it's also going to talk about introducing the low NOx furnace application, along with California's air quality districts that we're going to talk to you guys about for you guys out west. But again, that Lunch and Learn will be kind of again, just a refresher, but that's going to be on October 22nd, which would be the next Lunch and Learn. And that's going to deal more on the product side changes. Also, too, just another reminder, this is the first Tech Lunch and Learn that we're doing this fall. We'll be doing a second Tech Lunch and Learn, which I believe is going to be in the beginning part of November. With that Lunch and Learn, we're going to be going over some common install questions that we get in tech, along with some common troubleshooting calls that we do get in tech as well. in regards to furnaces and heat pumps, stuff like that. I'm working on putting that stuff together for you guys, but I will try to gear that stuff to, not stuff we've done in the past, because I know sometimes this can be a little bit repetitive on the most common questions that we get, like limits and pressure troubleshooting, stuff like that. So, but I'm also going to incorporate some install questions that we do get that you guys either may or may not see in the field. But that'll be the second Tech Lunch and Learn that we'll shoot for you guys. But that won't air until November. Well, it looks like I have answered all your guys' questions. It's been pretty straightforward on that Lunch and Learn as far as troubleshooting that motor and doing diagnostics on that motor. And if you were to come up on a furnace to determine whether you may have a motor or a board related problem. So again, thanks for joining us today on this Lunch and Learn. If you guys have any questions at all in regards to this topic, feel free to call us into tech and we can answer those questions for you. Again, also join us for the next Lunch and Learn, which will be the 22nd of this month. And we'll also have a second Tech Lunch and Learn a little bit later in the season here. So stay safe out there, and we appreciate you guys tuning in today. Thanks. Have a great day.